All right, Math 8 students, here we are, lesson 9.3, properties of rotation. We have done translations, we have done reflections, and now we are doing rotations. All of these are types of transformations. So before we get into our Explore activities, let's take a look at our essential question. How do you describe the properties of rotation and their effects on congruence and orientation of a figure? Now remember, congruence has to do, it's when we're talking about size and shape. Whoa, let's get the little pen going here. Talk about size and shape. And when two figures are congruent, they have the same size and shape. And orientation has to do with the way a shape, its direction, right? So it's top, bottom, left, right. So if you have a shape, is A always going to be in the top left? Or does it change? And is A prime in a different orientation? So those are the things that we're looking at as we take a look at rotation. So explore activity 1, exploring rotations. A rotation is a transformation that turns a figure around a given point. Okay, so it turns a figure. That point is called the center of rotation. That's an important vocab word. The image has the same size and shape as the pre-image. So right there in that definition, it told us that shapes in reflection, after being rotated, shapes after being rotated have this same size and same shape, so they would be congruent. So keep that in mind. Rotations are congruent from image to pre-image. All right, so what we've got here, the triangle shown on the grid is the pre-image. That means the starting one. That's the one you're going to transform. You will use the origin as the center of rotation. Okay, so that's the point that we turn the figure around. The center of rotation will not always be the origin, but in this case it is. Let me go ahead and slide this up just a little bit so we can see this activity a little bit better. Okay, move my little origin there. So first thing it wants us to do is trace triangle ABC onto a piece of paper and then cut out your trace triangle. Well, I don't have a piece of paper, but I do have my little shapes tool, so I'm going to move my little trace triangle over on top of that pre-image. Now, I'm going to rotate my triangle 90 degrees counterclockwise about the origin. The side of the triangle that lies along the x-axis, so side AB, should now lie along the y-axis. Right? So that would where side A prime, B prime would be. Just a little tangent here. Let's do a quick reminder on what clockwise looks like. Whoa, okay, let's try that again. Clockwise. Right? And counterclockwise. Not many of us have analog clocks anymore, so this is a good little reminder here. Clockwise to the right, counterclockwise to the left. So we are rotating this triangle counterclockwise to the left. So it starts here, and they said that that side AB, that's all along the x-axis, right here, should end up on the y-axis. So let's do that again. I'm going to rotate 90 degrees counterclockwise around the origin. And there's my new one. So then sketch the image of the rotation, there it is, and label the points ABC as ABC prime, right? So let's go ahead and do that. We have, this was C, so this would be C prime. This is B, we rotated that, this would be our B prime. And then A and A prime actually are in the same spot. Describe the motion modeled by rotation. So this is important to know when it asks you to describe motion with rotations. You need to make sure that you are addressing how many degrees it's rotated and in which direction. So in this case, we rotated 90 degrees. And it's written right there. You could use the degree symbol if it wasn't written. 90 degrees counterclockwise. Or about the origin. So you need to have the degrees, the direction, and the center of rotation when you describe rotation. Again, degrees, direction, and identifying the center of rotation. Okay? So Just a quick tangent here. Every quadrant represents 90 degrees. So if I go 90 degrees, I'm going to move from one quadrant to the next quadrant. If I go 180, I'm going to go across. That would be 180, right? And so 360 would be all the way around. So now I'm going to go ahead and do E. Check that the motion you described in D is the same motion that maps point A to A prime, B to B prime, and C to C prime. So A, since it's on my center of rotation, it's actually not going to move. So A and A prime do stay the same. B should go 90 degrees. It does, 90 degrees, right? Because this is a 90-degree angle. So it moves from here to here to B prime. And C moves 90 degrees to C prime. It's the same distance from that y-axis as it is from the x-axis here. So that is in the correct location. All right, so that's good. Checked. All right, now let's go ahead and reflect on that a little bit. Communicating mathematical ideas. How are the size and orientation of the triangle affected by rotation? Well, is size affected at all? No, size is not affected at all. Size has not changed. Okay, but what about orientation? Does orientation change? Yes. So how did it change? It was rotated 90 degrees. The orientation has changed from like what was up is now left. So we could say the orientation changed. It was turned or tilted. In this case, the orientation was turned. I'm going to say 90 degrees, counterclockwise, because that's what we rotated it by. And then I'm going to clarify what that did to our orientation, and I'm going to say what was up is now left. Okay. And the second question in our little reflect section here is, rotate triangle ABC 90 degrees clockwise about the origin. Sketch the result on the coordinate above and label the vertices A double prime, C double prime, B double prime, and C double prime. So I've got my second little triangle over here I'm going to drag. So I'm going to drag this triangle over here onto my coordinate grid. And I just made a different color so that we know it's a different transformation. Put my little center here. And then I'm going to rotate this one clockwise. So I'm going the opposite direction, 90 degrees. So I'm going to spin that. All right. So here it is originally. I'm going to go 90 degrees. And there's my new triangle. Okay. So then I need to label them. Since this was C, this would now be C double prime here. This is B. B is rotated 90. It's our second transformation, so I need to use two of those little tick marks. And then A is still the same here. A, try and find a space to write it. But since it's on our center of rotation, it has not changed location. All right, so there we've got two examples of rotation, both counterclockwise and clockwise, 90 degrees, and our center of rotation was the origin. So let's go ahead and move on to Explore Activity 2. A little bit big. So in Explore Activity 2, we're looking at the specific properties of rotation. Here we are in Properties of Rotations, our Explore Activity 2, and we are going to use trapezoid TRAP right here to investigate the properties of rotations. Trace the trapezoid onto a piece of paper. Include portions of the x and y axis bordering the third quadrant. Then cut out your tracing. All right, so since I'm not on a piece of paper here, I'm going to go ahead and trace using one of my little line tools. So I'm going to include the x and y axis on my third quadrant, and then I've got to connect my border there to my shape so I can make sure that I can move them all at once. I've traced my trapezoid. Okay, so now I'm ready to do something with that. I have placed my trapezoid and the axis on the top of those figures, and now I'm going to use the axis to help me rotate my trapezoid 180 degrees counterclockwise. So 180 degrees counterclockwise, and the origin is my center of rotation. So I'm going to move my little origin thing here right there onto my center of rotation, which is the origin. And then I'm going to sketch the image of the rotation in its new location and make sure I label my vertices T prime, A prime, R prime, A prime, and P prime. So I've got my tracing here, and I've included my X and Y axis, and I've included the trapezoid. So now that I've got these here, I'm going to go ahead and move this shape about the origin 180 degrees counterclockwise. So this is the counterclockwise direction. That would be 90. We know each quadrant will let us as a movement of 90 degrees. And so then this would be 180. Let's go ahead and do that again. So here's my starting. I'm going to move 180 degrees counterclockwise. So I've got 90 degrees counterclockwise, and then I've got 180 degrees counterclockwise. And that's where my shape is now. So now I need to label my new points. So R is my one that is closest to the origin. So this would be R prime. T is my one here that is connected. So that's kind of, sometimes it's nice to make those little connecting lines. And so this is T prime. Straight above T is P. So I'm going to straight above T. This would be P prime. And then our last point remaining here, our low kind of our, would be A prime. All right, so now I've got them all labeled. We're going to use a ruler to measure the sides of the trapezoid in centimeters. So I've got my ruler here. And remember, this is my centimeter side. I know that from previous experience I'm going to have parts of a centimeter, so I've got my millimeter side here too. 10 millimeters is equal to 1 centimeter. So let's go ahead and move that down here to our pre-image. And we're going to measure side TR first. So I'm just going to rotate that. It looks like that is about, right about 1.3 centimeters. So I'm going to write that in. 1.3, use my units, cm. I'm going to measure RA. I'm going to spin my ruler again. And so we've got 1.5, 5, 6, 7, about 1.7 centimeters. Measure side AP, which is this one right here. So I'm going to spin my, let's drag the ruler here. And then spin my ruler. AP, which looks like, okay, that's 1 centimeter. It's about let's see, let's line this up. Almost 1.5, looks like it's about 1.4 centimeters. And then I'm going to measure side TP, which is my long one. So I'm going to put that down here, rotate my ruler. I'm looking at about, what, 2.1 or 2.2? Looks like right about 2.2 centimeters. And then, of course, I'm going to have to measure my image. So I'm going to drag this up to my image. I'm going to measure side A, TR first. So I'm going to set that, spin my ruler, make sure things are lined up, and I should be, let's see, I'm looking at 1, 2, 3, so 1.3 centimeters. Since we know that things are congruent in, our shapes should be congruent in rotation, we can make an educated guess and say that all of our sides should be same length, right? But we're just checking to make sure. So now I'm doing side RA. Make sure my stuff is lined up here. I've got 1.567 centimeters. I'm going to measure side AP, so I'm going to slide my ruler, make sure my stuff is lined up. Rotate. It looks like I've got about 1.4 again, right? 1, 2, 3, 4. 1.4 centimeters, and then the long side here. Side TP. So again, what are we looking at? We've got 2 centimeters here, 1, 2, so 2.2. So what do we notice about the lengths of corresponding sides of two figures? They are the same. Corresponding sides are the same. Okay, so the next thing it's going to have us do, as it has been doing with translations and reflections, is we're going to compare angle measures. So we're going to measure all the angles of our pre-image, trapezoid TRAP. First angle we're looking at is angle T, so I set my vertex here. And this is a 90-degree angle, so it's a right, so I know that that's going to be 90 degrees. Make sure I use my degree symbols. Measure angle R, which is my top one here, so I need to slide that up. Spin my protractor. It is also 90 degrees. And you can tell that without a protractor, if you're looking at our grid lines, if they're lining up with grid lines like that, then they're 90 degrees. Measure angle A, which is not a 90-degree angle. It is an obtuse angle, so it should be greater than 90. And we're looking at about 110. Right? Looks like it's about 110. And then last one, angle P. So we're going to slide that protractor down, spin it. And it's an acute angle, so it should be less than 90. Oops. And we are looking at slightly more than 70, just a little more than 70, not quite 75, so let's go ahead and say about 72 degrees. Okay, and then guess what? We've got to measure the corresponding angles of our image, our rotated image, so a measure of angle T prime. It lines up with our grid line, so it should be 90 degrees, and it is. And is the same as our pre-image. Then we're going to measure angle R prime, slide that down. Also lines up with our grid line, so it should be 90 degrees, and it should match, so it is 90 degrees. A prime, slide that over, an obtuse angle, so it should be greater than 90. And again, we're looking at about 110 degrees again. And then we're looking last at angle P, so I'm going to move my protractor up there, spin it around so I can read my angles. It's an acute angle. I'm looking again right about a little bit less, sorry, a little bit, hold on here, line my stuff up. There we go. Right about 70 again, so right about 72. Because we know that they are the same size, same shape, so our angles should match. So then we go ahead down here to their questions. What do you notice about the measure of corresponding angles in the two figures? Corresponding angles are the same. The measure of corresponding angles are the same. And this aligns with what we know about rotation, and that should be that our size and shape remain unchanged because they are congruent. So what sides, looking at our one of our last questions here, which sides of trapezoid TRAP are parallel? Let's go ahead and move my protractor out of the way here. So I've got, well, these two are not, because eventually those two, they have slopes that are different and they will meet. But these two lines here, they run along parallel grid lines. So side TP, right, and side RA are parallel, because these two lines will never cross. So make sure you're using your correct notation here. Side TP and side RA are parallel. And, which of course wants us to find the corresponding parallel sides for our image. And that would be side T prime P prime and side R prime A prime. Those are also running parallel to each other. They have the same angles, as their pre-image, so they should also be parallel. So side T prime R prime and R prime A prime. Oops, not TR, that should be side TP. Prime. Sorry, it's going off the page there. I'm a little off here. And so what do you notice? Well, the sides that are parallel in the pre-image are also parallel in the image. Okay, so the last thing we're going to look at here is we're going to have another reflect question. Let's go ahead and size that up a little bit. And so we are reflecting. We're going to make a conjecture. Use the results from E, H, and I to make a conjecture about rotations. So what we're doing is we're taking what we noticed about side length, what we noticed about angles, and what we noticed about parallel sides to make a conjecture about rotations. So, what happens to size? What happens to shape? What happens to orientation? Did size change? Side length did not change, and angle measure did not change. So size and shape remain the same. So we can say rotations preserve size and shape, or congruence, right? Because that's what congruence is, the same size, same shape. But they change the figure's orientation by turning. And that's turning in a counter clockwise or clockwise direction. So if we trace our tracing back in its original position, then perform a 180 clockwise rotation about the origin, what do you notice about the transformation in B? So we've got to jump back here. So in the first thing, in our first transformation, we performed a counterclockwise 180, and now it wants us to perform a clockwise 180, right? So let's go ahead, and we're going to take this back to its original position. Okay, and so what we did is we went counterclockwise. What it wants us to do now is go clockwise 180. So what do you notice? Counterclockwise 180 ended here, and counterclockwise 180 ended in the same location. So comparing the results, what do we see? 180 in either direction, counterclockwise or clockwise, will give us the same result. So we can say a 180-degree counterclockwise rotation and a 180-degree clockwise rotation will give the same result, or will give the same image. Will result in the same image. Right? Image being the after, pre-image being the original. So how do you actually graph rotations? Let's take a look here. So the figure below shows triangle ABC. We want to graph the image of the triangle ABC after a rotation 90-degree clockwise. So I've got my triangle here, and I'm going to rotate that triangle clockwise 90 degrees. So to do that, what we need to do is again, one point at a time, okay? Point A is at our origin, which is our center of rotation. And so A is not going to change. It's going to be A prime. It's on that center of rotation. It doesn't move. Point B is 2 units to the left of the y-axis, right? So you can see that it's 2 units to the left here. So a 90-degree clockwise rotation would put it 2 units above the x-axis. 2 units to the left here, 2 units above here, right? So you can think that you go up 3 over 2, and you need to reverse that over 3 and up 2 to get that rotation. Point C is 2 units to the right of the y-axis, right? So here we go up and over. So you need to do the same thing again in reverse. You need to reverse those two little, and you need to go over 3 and up, and that would give you C. Being able, traveling along the axes is going to be a little bit of a hint there to help you out, because the axes, one axis to the other is always going to be 90 degrees. Okay, so if you can connect those points to an axis and rotate that 90 degrees, it's going to be a little bit easier to rotate that shape. So then we're going to go, so A prime stays the same, B prime, up and over is connected, so we go over and up, same distance. C prime, up and over the other direction, so over and down, and we rotate that. And this is what that's going to look like I'm going to give you a little animated rotation here. So let's go ahead and rotate clockwise 90 degrees to check, and there it is. So a pre-image, 90-degree clockwise rotation, image. All right, and then you connect those points. So here again is both of them. So we've got triangle ABC, and then triangle A prime, B prime, C prime, which is our image, after a 90-degree rotation clockwise around the origin. So, and our final little reflect here, is the image congruent to the pre-image, and how do you know? Well, we know that by definition, rotations preserve size and shape, so that should be enough. But how can we also double check that? If we look at our image and our pre-image, the side lengths measure the same. So we know that it's the same size, and the angles should also measure the same, right? They have the same intersection points, so that would preserve shape. So we can say yes, you can see from the grid squares that the lengths and angle measures are the same. So yes, it's congruent, and you can see from the grid squares side length go down here, and angle measure are the same. Could you also use a ruler and a protractor to measure that to double check? Yes, you could, and that's what we did in Explore Activity 2. So the last thing that you need to do here before we have class is you need to go ahead and do the your turn. All right, guys, it was another long one, but hopefully you were able to get some important information out of that. If you had questions as you went through, please make sure you wrote those down, and we can talk about them in class.